Welcome to another math problem of the week. 5 identical circles, square, and radius r. Let's talk about it. For this question, we have a big square, and this is partitioned into 4 congruent triangles and a quadrilateral. After that, we place 5 identical circles into it so that it is tangent to the side of the triangle and the quadrilateral. If the length of the square is equal to 1, we also find the radius of the circle. And the options are A, 0.183, B, 0.185, C, 0.189, and D, 0.191. What do you think?
Pause the video now if you wish to solve it. Keep watching the video once ready.
This question can be easily solved using Pythagoras theorem. In fact, the 4 congruent triangles are actually right angle triangles, and we are going to show that now. Suppose we are given a right angle triangle with the length AB and the hypotenuse C. We can make 4 copies of this to form a square, like what I have here. So, for this square, we partition into 4 right angle triangles with the length A, B, and C. And so, this length here will be equal to B minus A. And since all of them are B minus A, and this is a right angle, so this is a square. So what we have here, the area of this big square is equal to C squared. And it is equal to 4 of the smaller triangle. Each of these is of the area half AB. And in the middle, we have a square of the length B minus A. So after we expand this, we have A squared plus B squared minus 2AB. And this is also 2AB. So we have only A squared plus B squared. With this, we prove a Pythagoras theorem. And now we are going to use another theorem regarding the right angle triangle and the in circle. So what I mean here is, this is a right angle triangle with the length A, B, and C. And this is a circle that touch the 3 sides of the radius r. So we know that this is also of the length r, and this is also of length r. So what we have here is, this is of length A minus r. Note that this segment is a tangent to the circle, and therefore here also will be the same as A minus r. Similarly, the length of this segment will be B minus r, so that the sum equals to B, and therefore this is also B minus r. Therefore, we know that C will equal to B minus r plus A minus r. It means that C will equal to A plus B minus 2r. So these are the 2 results that we're going to use to solve this question. If you enjoyed this video, please like, comment, and subscribe. So I'm going to write this as hypotenuse 1, and this is r, so that this whole thing here will be equal to 2r. If let's say this is A, then we know that this is also A. And therefore, we have the triangle of the length A, 2r plus A, and 1. So using the Pythagoras theorem, we know that 1 square equals to 2r plus A square plus A square. And using this idea, we will know that C is equal to A, that's A. B equals to 2r plus A, 2r plus A, minus 2r, minus 2r. So from the second equation, we know that A is equals to half. Since A equals to half, then from the first equation, we know that 1 will equal to 2r plus half square plus half square. So we are going to solve for r. Then it means that 2r plus half square equals to 1 minus 1 over 4, that is 3 over 4. So 2r plus half will equal to plus minus square root 3 over 2. And therefore, r will equal to negative 1 plus minus square root of 3 over 4. Let me continue here. Since r is of positive value, so we will have r is equal to negative 1 plus square root 3 over 4. And using calculator, this is about 0.183. And therefore, the answer should be equal to A. So the approach that I present here is by using these two results. One is Pythagoras theorem, and the other one is the relation between the R and ABC for a right angle triangle. And for now, let's look at other people's solution. That's all for today's lesson. I'll see you again next Tuesday. Bye bye.